All right, electromagnets and solenoids. This will help you to create a better electromagnet and will also allow you to do the calculations with the solenoid questions. So, basically, what an electromagnet has is a coil of wire around some ferromagnetic material. So it's usually like iron. That's a nice magnetic material inside. If it's empty space inside, it works. You get a magnetic field, but the magnetic field gets to be stronger if you've got some sort of iron in the middle. So an iron core is often what we say. These are two different types. These are electromagnets, solenoids. The two words are often used interchangeably. So when you hear solenoid, just think electromagnet and you'd be fine. But see how this one has the wire really tightly wrapped together. Okay, that would make a better electromagnet, is to have, what you want is more coils per unit length. So the real one of the important things is that it needs to be longer than it is wide. Okay, so you can't just wrap this little bit here because then it's about as long as it is wide. So you want it to be significantly longer than it is wide, but you might want to leave a little bit of extra space here at the end. That's a hint, hint. All right. The equation to calculate the magnetic field, B equals mu naught I N over L. Okay, so mu naught we ran into before, and it is 4 pi times 10 to the minus 7. That's just a constant. It's the permittivity of free space, I think. I is your current, so that's in amps. N is your number of turns. Okay, so you see how N's on the top? So more turns, if we have more turns, more wrappings, then we should get a bigger magnetic field. And then L is the length. Okay, so more turns for a shorter length, but remember your solenoid does need to be longer than it is wide. So that's a happy balance. So this is the length of the solenoid in meters. So we're standardizing our units. That has to be in meters. The unit for your magnetic field, remember again, is Teslas. Strengths of magnetic field we can expect from our solenoid are on the order of 1 millitesla. Okay, which is stronger than the Earth's magnetic field of something times 10 to the minus 5 teslas. So this is 10 to the minus 3 teslas. So it is stronger than the Earth. So one of the things to remember is this is an electromagnet. So this is connected to some sort of battery. So each end of this, and this would be stripped so that it was metal touching metal, stripped so that it was metal touching metal, and you have a complete circuit. Now, if we're the current, let's think about this. The current goes from the positive terminal to the negative terminal. So if the current is coming out of the positive terminal, it's coming this way here. And then we can do our right hand rule. And do you see how this is wrapped over the top? Okay, so the current's going over, and then it's coming under on the bottom. So take your hand, and your hand is going to look like this. So your thumb here is going to point in the direction of the magnetic north. So see how my fingers are wrapped in the direction of the coils. The coils are going this way. My fingers are wrapped over the top so that my thumb is going to point in the direction of the magnetic field. Had this been the positive, then the current would have come in this side, and I would have made my hand go the other way with my thumb pointing this way. So you can take your pencil, and if it's coiled, if the current's going the other way, so from the bottom in and over the top towards you, then your thumb will be pointing this direction, and that would be magnetic north. If we put a compass here, okay, this is north, so the south end of the compass would point towards the north end of the electromagnet. So here's kind of the important things if you wanted to make a stronger electromagnet. You want a higher current. Okay? Think of how you can get a high current. You want more turns, which basically means you want them tighter packed together, or you want like more wires going at a time. And then you want it to be kind of shorter, but not so short. Remember, short this way, that it is wider than it is short. So you still want it to be longer than it is wide. Okay, so here's our length and here's our width. We want it to be longer than it is wide. And so that will get you the best electromagnet. If you have a higher current, more turns over a shorter amount of time. So get those little coils packed as tightly as you possibly can. So hopefully that will help you build your electromagnet, and it will help you with the calculations involving electromagnets, because now you have the equation. And remember, standardize your units, so your length needs to be in meters and your current needs to be in amperes, not milliamps.